que je préside ce jury. Est-ce qu'on peut... Ah, yes, yes. Merci. So, just a technical thing. At the same time as the Zoom, there will be a YouTube stream. So I'm going to send you the address, just in case there is a problem with the Zoom, you can still follow the presentation. So let me find that. And we are going to start by presenting the jury. The defense will be in English, as the manuscript was. So Thesis Seng is going to present his PhD defense today, and in his jury there are two reviewers, Laurent Eute, sorry for the pronunciation, let me know if it's not right, who is from the University of Rouen, Normandy, Mounim El Yacoubi, who is from Télécom Paris Sud.
Oui.
There is also Muriel Visani, who is examinatrice, I'm not sure how to say that in English, from examinator, examiner. From La Rochelle University, and she is actually working in Marseille. Vincent Charvilla, who is the director of the advisor of this PhD. Axel Carrier and Wei Song Oi. So Axel is also in the team, and Wei Song Oi is from Singapore, from National University of Singapore, and is also one of the co-head of IPAL, which is the Singaporean and French lab in Singapore, and myself, who is also a local person from Toulouse, INK. So Travis, you have 45 minutes to tell us about your work, and then we'll go for questions. Please.
Thank you.
Thank you everyone, and especially the member of the juries, for attending my presentation. I am Travis Seng. I'm going to present you the work I did during my PhD, which is titled Multimodal Analysis of Video Lectures for Better Learning Experiences. So obviously everybody knows video lectures, right? But did you know that there were different types of video lectures? So the most common one is what I call the slide-based video lectures, where it's a video where the teacher presents its work with the slides, right? And then you have some other subtypes where it's a recording of the presentation. And then what you have also is the blackboard type of presentation, where you have the teacher writing on the blackboard, and also it can interact with its students. So one question we can ask is, do people actually use video lectures or still use it? So COVID-19, ever since COVID-19, a lot of universities recorded a lot of online classes, and they had to resort to online classes because students couldn't go to classes anymore. So they provide, for example, on this YouTube channel on the bottom left, this is a YouTube channel from MIT. They provide these courses and also other, like some courses for free online, right? And you can see that this channel provides a lot of video. Like they have more than 7,000 free videos. And I'm sure some of you know this platform, Coursera, EDX, and Khan Academy, which are platforms that provide online classes which rely heavily on videos. And they're getting popular because now they can deliver certificates that are recognized by companies, etc. So one of the questions we can ask is, like, why do people use it? Like, do video lectures have benefit? So obviously they have benefit. They can allow for like learning at their own pace. You can pause, you can go back, you can review content. And also, you can actually learn it from your home, right? You can learn from anywhere. And more importantly, you have access to subtitles. You can zoom on the video. And this is something that you couldn't really do when you attend a class. There's still a problem though, is that even though I show that there are benefits, most videos are really long. So here's a sample of some videos from randomly picked videos from the MIT OpenCourseWare YouTube channel. And you can see that most videos range from 30 to more than 1 hour. So the videos are really long. And this can cause an issue because since the video is long, it's quite troublesome to find something. Like if you have a specific topic in mind, you can have trouble to find it within the video. Also, since it's online in the static content, you couldn't really interact with the presenter, with the teacher. You can ask questions if you find yourself blocked. And like long video, obviously, like it's harder to stay engaged because like if you have 1 hour long video and you have to only watch the video, you will be distracted by a lot of things since you're not at class. So in order to fix that, we want to make an analysis of the source of information that we have at our disposal. So what is the information that we have? Well, they come into 3 modalities, main modalities. So the video, the visual, like what you see, the audio, what you hear, and the text, what you can also like read. And all these modalities are contained into all this information on the right. So it can be contained in the slides. It can be contained on the Blackboard if it's a Blackboard type of video. And then you have other information such as the mouse, the pointer territory, and also the teacher can provide additional material such as PDF. And yeah, you have information that you can use. So now that we have stated the context, we can state our problem, right? So the problem is that lectures video does not really achieve their full potential due to all the changes that I told you about. So the goal of my work was to investigate how we can use multimodal analysis, how we can use the video, the visual, the text, and the audio to improve and enhance the usability, the education value of lectures video. Right? So now that I explained the context, so now let's suppose that you couldn't watch my video, like you missed my video, you missed my presentation, and you want to watch the video yourself at home. And actually, since the beginning, we are in the video. So if I move the cursor, you will see that we are in the video, and then if I put the sound, you will hear myself speaking. Yeah, well, they will. So there we reflect. And here, what we can see is the interface I developed during my PhD. So in this interface, let's say you want to watch my video, and it's very long, right? Like, it's 1 hour long, and you don't have a lot of time. But what you can do is that you can go see this visual timeline on the bottom, and then you can easily see the slides, extract the slide from the video. So everything was done automatically. So let's say if this figure intrigues you. So you can click on it, and then the video will go directly to the beginning of this slide. And now let's say you couldn't, this figure is a bit small, right? You want to be able to make it bigger. So what we can do is that we can go into this interactive layer, and now everything can be moved, right? Everything can be zoomed. So we can zoom like this so we really see. And actually, it's not only the figure, it's actually everything, like the titles, the bullet points here, everything can be moved. So now we can wonder, like, you can wonder, how I dig that? So we run an object detection algorithm which is trained on synthetic slide. And this will be my first contribution that I will present to you later. And now, let's say that you want to see maybe other sections of my presentation. So there's a review that says that people prefer to watch smaller videos, right? 6 to 10 minutes video instead of watching a 1 hour long video. So what we can do, what we did is that we provide automatically generated chapter that will, that you can click on it and then you can arrive on it. So how we do that will be presented in the second contribution that I call temporal video lecture segmentation. And now, maybe you might wonder, like, what other features do we have in this interface? So what we can do is we can use either the transcript here to search or the slide content. So we can search through these two modalities. And if I type interface, we arrive to the slide where I talk about it. And then you can see actually the search results on the yellow on the bottom. So we'll see that I will talk about that again later. So now, let's go back to the real presentation. Okay. So now I want to review like the existing the rated work of educational applications, right? So right now I just show you a demo of interactive educative application. So I just wanted to show you quickly what was the state of the art of educational applications. So here a quick sample of some state of the art about educational application. So we can see that most of them focus on 3 main aspects, I would say. So we have the indexation, the summarization, and the accessibility. So these 3 domains are the main focus of these applications. So now we just explain to you quickly what each of them does. And you will see that this interface looks a bit like what we did because we were inspired by them. So first of all, on the left, we have the work from VideoCan. And this is just an interface that tries to extract the most relevant words into a phrase cloud, and then you can easily search through it. Then we have on the right another work from LateWise that use subtitles from YouTube, and then they try to summarize it, and then you can easily search through the summarized content. Another work, so this one is called Lecture to Note. So they try to transform a video into a note. So what they do is that they extract the visuals and the text, and they run optical character recognition to know what is said by the text, right? And then they try to merge the corresponding text to the corresponding text on the slide, and then they can make a note with the image as well. And then we have another work which focused on accessibility. So this one tries to detect the elements that was not described during the speech of the presenter. So this is a really accessibility focus for people that are visually impaired. And same, what they do is that they run content extraction to extract the elements, and then they run a caption algorithm on it. Another one, Smart Learn, which tries to also match the speech and the text, and then they show it. And one feature that, like the contribution of their work, is that they also provide a constant speech rate. So it means that you can set a speed for the speech, so it will be constant, and you can make it slower or faster. And then finally, we have the FeedVid interface. So this work tries to make video responsive. They try to make video presentation responsive. So first of all, if you were to watch my presentation on a mobile phone, on your device, you will feel that some texts are really small. So what they do is that they try to also match the text and the speech to make only appear the relevant element. So we have only, for example, only the one bullet point at a time, maybe one image at a time. And you can even hide the presenter, the teacher, and you can hide also the template, the background. So now we did a quick review of related work on education applications. And what we can see is that most of them like rely on visual entities extraction. They rely on analysis of the slides. And so what we want to do for our first contribution is that we want to improve this aspect because we felt that the performance was not the best that we could have. And yeah, so this will be our first contribution. So the visual analysis. So our solution is to make a synthetic slide generator. So before I go a bit further, let me just do a quick reminder about visual analysis. So what is visual analysis? Is a method is visual analysis we use. What we want is to detect the object, the elements in the slides, right? So we want to do object detection or semantic segmentation. So object detection is the localization of the element into the image, and semantic segmentation goes a bit further. It tries to assign a class to each pixel. So this domain has been like such ever since a long time. So the first breakthrough was around 2015. So it's something that is known and have been researched very well. So in this section, we use YOLO, FastRSN, and MaskRCNN. And these are not state of the art, but they provide off-the-shelf models that we can use, that we can train. And they work very well as long as we have data. This method works very well. You can train it as long as you have a lot of data. So the first issue is that we search through the state of the art, like what was the slide dataset? What were the slides that provide, what was the dataset that provide the slide annotations? So you can see on the top the two first datasets that they don't have a lot of images, right? And they have a lot of classes. So it will make the training very, very bad. I mean, it would be hard to generalize and make it work on unseen data. So then we have two other datasets, so FitVid and SlideVQA. And the SlideVQA one has the most data, 32,000, and we can say that we can use that to train something. So let me just show you some first sample of, So now let me just show you samples of FitVid and SlideVQA. So the classes in FitVid and SlideVQA are different. So in FitVid, you have 9 classes. You have the title, the text box, etc. And in the class VQA, you have other classes. And you can see that only three classes overlap. Like they only have 3 classes that are the same. So what it means that people that work on slides annotate for their applications. For example, FitVid, the goal of FitVid was to hide, for example, the presenter. So they added an instructor classes label into the dataset. But for SlideVQA, they don't need it, so they don't have it. And one thing important is that they have the object text class. So the object text class is all the text on an image, right? So on this picture, you can see that there's different labels for the text, right? So for example, there's the title on top. On the bottom, there's another label, which is called page text, which is the text on the slide. And then you have also other text here, which is the text on the footer, on the header. And then you have image object text, which is text on the diagram, on the image. So this difference, so difference is makes it hard to, we couldn't use the same dataset to evaluate on the other one. So we also found that there was some mislabeling in the SlideVQA dataset. So this is 2 samples from SlideVQA dataset. And you can see on the left that this is labeled as diagram, this figure. And then we have a similar figure, but this is labeled as table, right? And then we also see that this is labeled as table. There's some errors. But above all, we can see that this here, you can see that the text here was labeled as object text. But the text that was on the right, the percentage here, was not labeled at all. So, and yeah, there's other example of this. Like on this on this picture, also a sample from the SlideVQA test dataset, you can see that there's a lot of object text that are not labeled. Like all the text here are not labeled at all. And this will cause an issue later for evaluation. So in order to improve that, we propose a solution, which is a synthetic slide generator. So this is a solution that allows people to automatically create and generate customized annotated datasets. So you can customize the classes that you want to use, and you can also have different output. So you can generate datasets with bounding boxes, segmentation mask, and also text. So how it works is that we have 4 components, the content. So the content component use the Wikipedia HTML page. So we just use the Wikipedia articles, and then we parse the HTML page. So we get all the information. So we get the title, we get the headings, we get the images, and then we get the paragraph. And then what we do is that we use this content, and then we run it through a small LLM to transform it to a more suitable slide content. So we transform the big paragraph into bullet points. And what we have at the end is a summarized content with images. So for Toulouse, we will have a section of geography with bullet points located in the north of Haute-Garonne. Then we have other sections like that. So now that we have the content, what we do is that we pass it through our layout component. So we use MARP, which is a tool that it can use text to transform to HTML slides. But we modify it so we can output different layouts. So depending on the content, for example, if you have one bullet point, an image, it will create this kind of slide. So if you only have the image, it will create this slide. If you have 3 bullet points, maybe you will have this other layout. So what it means that now with just one Wikipedia article, you can create up to 20, 30 slides, depends on the length of the article. And now, what we do is that we have a style component. So the style component will try to make it easy to change the style, the colors, and the font. So all the elements you can see on the right to make different and more diverse slides. So we try to make it close to real slides. So we don't try to use too much funky font or colors. And then we can create the annotation. So as I said earlier, the slides that we created are HTML pages. So now we just parse the HTML content, and then we can get back the bounding box and with the classes. And then you can see that, first of all, we tried for the same picture, we can have the SlideVQA version or the FitVid version. So in the FitVid version, you had a label that was called handwriting. And but it doesn't exist in SlideVQA. So this is here labeled only as image. So you can customize your classes. And then you can also have mask, segmentation mask. So this is, to get this, we also use the HTML, and then we use also a JavaScript tool to compute image differences with each element. Because in HTML, you can hide elements, and then we hide an element, and then we can compute the mask. So now, here's some example of general slides. So some of them looks almost like it was made by a human, right? I don't know. And so what we do to see the performance and the improvement of our solution. So what we do is that we use the YOLO V8 and faster ascent model, and then we try to train on the FitVid and the SlideVQA datasets. But also what we do is that we augment the original datasets by adding the synthetic slides, the generated slides. So now we have 4 datasets. We have the base datasets and the augmented datasets. And here are the results that we can see on the test sets. So first, maybe what you can see first is that for SlideVQA, we have a really low improvement. So This is explained because, as I said earlier, the dataset is a bit, like for example, the object text on the label correctly, and it can cause an issue for evaluation. I will show you a bit more example later. But for FitVid, you can see that we have a big improvement. And it can also be explained because FitVid didn't have a lot of data at first. So obviously, like when we had more and that data, we have a big increase. Another experiment that we run is that we try to test the performance when you train on the dataset ServiceQA, but then you have a different real and synthetic data ratio. So for example, when you only have 50% of the real data sets, if you add the synthetic slides, then you can almost achieve the performance of the full data set. So what it means is that you don't have to annotate that much. You can only annotate half or even less, and then use our tool to add more synthetic data. And so it reduces the needs of annotation, and then you can save time. So earlier, so here now, here's some qualitative results. So when we train only on the base FitVid dataset, so without our improvement, without our synthetic slides, you can see that there are some problems here. So first of all, the text box are overlapping, and then we don't really detect this text on the bottom. So now, when we train with the augmented one, we fixed all these problems. And now, so on ServiceQA, there was this image I showed you earlier. When you see that we detect a lot of object text, right? So this is trained on the base ServiceQA dataset. So you can see that it seems good. Like we detect an image, a caption. On the side, we detect a title and the image itself. But the mean average precision, the metric that shows how well we detect and we are correct compared to the ground truth, is quite low. So now when I show also the augmented one, we're a bit better, but it's still quite low. So, well, you can explain because the ground truth was actually like that. So, and this is present on some other image where there's a lot of image, when there's diagram with a lot of text, this happens again. So, so one more result is that I said earlier that we can generate text, some text annotation, right? So what we can do, and what we try to do at some point, is that we can transform a slide and then to a text array, to a textual representation. So it's almost like when you pass an image to ChatGPT, you can ask him like describe the image maybe, and then he can almost give you something like that. So we tried to do that by training a Pix2Strike model, and it worked quite well actually at the time. But we didn't run any more evaluation, but our tool can create, this is just to show that the tool can create a lot of different annotations type. So now the takeaways, right? So now our solution make it easy to create dataset, customized dataset, where you can change the classes and also the type of annotations for different applications. First of all, if an application needs to detect the presenter, the teacher, you can have it. If you need to detect the handwriting, you can also make it. It allows for better performance, so better precision and reliability for the classes, for the performance, for the prediction of the boxes. And also, we saw that it reduced the need of annotation. And this work was published into this conference, IGDAR, in 2024. So now that I talk about the vision analysis, let's focus on the temporal segmentation that I teased you earlier. So temporal video lecture segmentation. So what is the problem, right? So we want to, so I said earlier that there's a lot of long video, and we want to be able to segment this long video into shorter clips, right? Because review said that people prefer to watch shorter content. They're more focused. The problem is that there's a lack of labeled dataset, so it's quite hard to do use some kind of supervised methods. And also, what we want to do this time is that we want to make it work on different kind of videos. So the slide videos, the Blackboard type of videos, and also videos where there's only the teacher speaking. So what we did before was a quick related work. So here's some like state of the art of all the solutions that people use to try to segment slide video. So you can see that some of them were unsupervised, some other were supervised. And like all the first methods only worked on slides, but the last one, the one that we call AV lectures from Gupta, tries to make it work on slides, blackboards, and other videos that don't fit the slides and blackboard type. And what they use is that they use the image, the video, the audio, and transcript. So what we did is that we looked at this work, and we saw that there was some area to improve. So they work. I will just explain their work and what we do a bit differently. What we do differently. So what they do first is that from a video, a long video, they segment the video into 10 to 15 second segments. And then what they do is that for each segment, they have, so they can get the transcript. So they have the image, they have the video, and then they have they also get the OCR, the text which is on the video. So if it's slide, they just try to get the text that you can see on the video. And when they do that, so there are 4 different information that they pass through what we call like pre-trained model, feature extractor. And then since these embeddings that you get at the end are not aligned, they don't share the same latent space, what they do is that they try to align them using a contrastive training. And now at the end, they have multimodal embeddings, and then they use an algorithm called TW Finch to try to cluster them into segments, into like groups. So at the end, you get your final segmentation. And TW Finch add a temporal proximity term to make sure that the first segment stay with the you don't segment the first segment with the last one, for example. You have some temporal proximity. So now what we do, so now we propose our contribution, which is, so we saw that there was some weaknesses and ways to improve this algorithm. So what we do first is that we run video type classification. So AV lectures, the solution, they don't really differentiate between slide video or blackboard video or other video. And we thought that we should, because each video has their own information, right? So some slides have has way more textual information, is way more structured than blackboard video. So we run a visual analysis from the previous chapter, and then we look at the video. For example, if you see that there are text boxes and titles, then it would be labeled as a slide. It would be classified. The video would be classified as a slide-based video. If you see that they're blackboard, then it would be if you see that there's handwriting and teacher, like in this video, then it will be labeled as blackboard. And when these conditions are not met, it will be labeled as other. So now that we run this, we do a bit like AV lectures. So we segment the video into segments. And then we also detect the cuts. So for example, in slide video, there's a lot of cuts. Like every time I switch a slide, it's a cut. And this is something that they don't use in AV lecture. So we try to detect that. And then what we do is that we now run the embedding computation. But the thing we do differently is that we don't use the video embedding, because we experimented with it, and then we saw that there was no benefit at all. And sometimes we can even have worse performance. So for each information that we have, so now we have the image, we have the transcript, and then we have the OCR on the image. What we do is that we extract the embeddings with pre-trained model. But the problem is the same, is that the embeddings are not aligned. Like the visual, the image, and the text model are different, so they don't share the same latent space. So now what we do is that we try to align them. So we form 2 embeddings. So we concatenate the image and OCR embeddings to form the visual embeddings, and then we just keep the transcript separate. And what we do is that we train with a contrastive loss. We use the same loss as a current LLM or model like image text models, which is info NC. And we project the visual embeddings to the same dimension of the text embeddings, and then we try to align them. So the way we align them is that if the visual embeddings and the text embeddings come from the same segment, it will be pushed together. But when it's not, it will be pushed apart. And yeah, we don't project the text embedding in this case, which AV Lectures does. So now that we have our alignment model, we just predict like multimodal embeddings for each segment that we have. And now what we do is that now that we have all the multimodal embeddings from each segment, we use TW Finch to cluster them together to get the final chapters. But the thing we do differently is that now we have the detection of the type of the video, we use the information differently. For example, when we know that we work on slides, we will use the transcripts, the visual, and the transition information. But when we are working on Blackboard, we will only use the transcript and visual because there's few and there's not really a lot of transition information in this type of videos. It's just like a camera following the person. And then when you don't have anything, when there's just a presenter speaking and there's no visual support, we only use the transcript to cluster. And so what we do to use this transition information is that we add the term into the distance that is used by a TW Finch, which is like a structured term that will help to cluster the segment that come from the same slide. So now that we have that, we want to run an evaluation to see if our method performs better. So we have at our disposal 3 datasets. So we have the AV Lecture dataset from the paper, the previous paper. But this dataset is a bit biased. I mean, yeah, it's somewhat biased. It's because to get some of the annotation, what they do is that they take 2 videos from the same model, and then they concatenate together to create artificial boundary. And so that's how they get some of the annotations. So because of this bias, we wanted to introduce 2 more datasets. So we have the video lecture slide dataset and YEL dataset that were all scrapped from internet. So they were scrapped from YouTube. And so how we got the annotation is that in these videos, we made sure that it was the authors that provided the annotation. So it was for these 2 we got annotation from the authors themselves. And so now let's show the result on the AV Lecture first dataset. So here's our method. So we show that our methods perform better than Gupta et al. And just a quick reminder of the metrics, because maybe it sounds a bit, you don't have information on the metrics. So the first one, BS at 30, means a boundary score at 30 seconds. So it means like how well you predicted when your boundary is close to the ground truth at the 30 seconds tolerance. And then the RU is just how well your segment match with the ground truth one. So we see that we improve especially the boundary score. And this is due to the fact that we now use the transition information. And then here are 2 more results. More results on the 2 other datasets that I show you. So the first one, video lecture slide datasets, we saw that we have a big improvement. And this was kind of expected because they mostly rely on slides. I mean, they only have slides. And our contribution of using transition information applies to slides. So that's why we get a big increase in performance. And then we have our YEL dataset that has a lot of Blackboard video, like not really, don't have a lot of slides video. And you can see that we still have a bit more performance, but yeah, not as much as not as much as a huge leap than before. And one thing we notice is that we have a high IOU for the naive method of YEL dataset. This comes from the fact that most chapters in the Yale dataset are the same length. So obviously, when you split equally, then you have a high, like more than will have somewhat a good performance in IOU. So now, so this work, we wanted to do some other. We wanted to run more experiments. So we wanted to use, for example, the information of the blackboard. So for example, if the presenter is erasing the blackboard, or if the presenter is starting writing, we wanted all to use these events to help the algorithm to cluster in a better way. And then also we want to try to find a way to fine-tune. We also experiment with fine-tuning LLM using this different information that I just show you to see if we can improve the performance. So we want to publish this work in WCV 2026. So now that I talked about the temporal segmentation, let's go back to the demo I showed you earlier, right? So I call this interface like Video Lectures Analysis Toolkit. So the problem is that most of the interface, the related work I showed you, all of the educational application I showed you earlier, they are not really like open source. They're not open source at all. Like they don't provide any way to run their code or to reproduce their results. So what we wanted to do is that we wanted to make an open source application that implements the contribution that we did, but also try to take the good features from these applications. So here is the interface that I showed you earlier, and on the right, actually, we have the tabs. We have the different tabs, and these tabs show the different modalities. Actually, I mean, here we have the transcripts. Here we have the chapters that we get thanks to our second contribution. Here you have all the transition, all the cuts of the video. And then on the right, you have all the OCR, all the results this is all the text that are displayed on the slides. So now what we can do is that we display in an event timeline. We display the information we can also display the information into two timelines. So we have the event timeline that shows the cuts. Like the cuts are in green. You can show the chapters, which is in blue. And then you have the search results in yellow here. And then I showed you earlier, but you have the visual timeline that shows the slides that were extracted. So you can easily repair yourself. You can easily look at this timeline to have a linear view of the whole video. And then the features I showed you earlier is that you have all the elements are interactive, right? You can move everything. You can even hide something. For example, here the same slide, but in different, with different arrangement. So there was a presenter, I had it before, now you can see him. And now what we can also do is that when the presenter is saying something, is there a link, a semantic link with an element in the slide? It will be highlighted. So here we can see an highlighting with a green glow. But we can also do the opposite. So now if you click on an element on the slides, you will find on the right all the times where I talked about it in the transcript. And now we have the translation feature. So we have the English version of a slide, and then you can also have, like, for example, on the fly, a French version on the same slide. So this interface allows that. So I show you so far all the features that we have right now. But what we want to do is that we want to adapt the interface for other types of video. So I mainly talk here about slide-based video because they are the videos that are the most structured, and they also, it's the video with the most visual information, right? And Blackboard is a bit harder because we want to make it work on Blackboard, but it's hard to, it's way harder to segment and to understand what is written on the Blackboard. So also we want to display more information. So we want to be able to display live annotations, like when the presenter started writing on the, for example, on the slides or on the Blackboard, and maybe also make use of the gestures, because for example, if the presenter is making big movements, maybe it means like something's happening. And there's a work, in future work, we will focus on the accessibility. That is currently, in future work. So we submitted this work, this interface to the ACMMM open source track of 2025. So now the conclusion. So far I made 4 contributions. So we published in 2 conferences, and then we submit in 2 more conferences. And to conclude, so at the beginning, I told you we wanted to use modalities to get at the end some sort of a better way to better learning experience. So what we do is that we did that by creating and developing an interface. But what we want to do, what we want to do more is to focus more on accessibility by using user study. And also another thing is that we want to use more modalities, right? We want to use more information. We want to use the Blackboard, for example. We just want to, we want to explain our work to Blackboard, for example. And I would like to conclude by saying that we can see my work. No, it's more like, so my work, when I started my work, there was like ChatGPT, the LLM was not really known to the public, right? And now everyone is using it. So I like to see my work as a way to transform, to analyze all of the information that we have available and make it easily parsable, usable by now LLM. So now you can use LLM for example, to have a summarization or to get to be an assistant to help you answer your questions easily. Because the LLM doesn't really like to can process 1 hour long video, right? So we made it possible in a sense to make it readable by LLM through my work. And this is a quote from Andrew Karpathy, that was before the head of AI in Tesla. So he says that LLM don't like to see, they like to read, they don't like to navigate, they like to scrape, they don't like to click, they like to curl. In a sense, we made it. Our work made it easier to read video lectures for LLM, for other applications. So, thank you for listening, and and I hope you have questions.
Thank you for the presentation. You still hear us well? Yes. So we are going to start with the questions, and we'll start with the reviewers and maybe with Laurent Hutter.
Thank you. Do you hear me?
Yes, very well.
Yeah? Okay, good. Thank you. So thank you for this nice presentation, and make some effort to present things with the same plan as a manuscript, but with other figures that illustrate some of your work. So it was good for me to follow your presentation. I was also very happy to see the first part of your presentation with the demonstration of what you are able to do with your toolkit. It's a nice way to introduce what you did on your work. I had a lot of pleasure to read your manuscript, except for some point I will discuss with you and ask you for some questions. But I understood a lot of things, and it was very pleasant to read. This is very good work, some nice contribution, a nice view of the state of the art, some nice experimentation, and so for me it was a good way to go into this topic of video editor. I'm sorry because I sent my report very late, so I apologize for that. So I have some questions, but I will refer to the manuscript. Also, there are some questions in my report. The first one is about the questions about the synthetic slide generation. So this is a nice way to generate synthetic data. It's good, okay. But I didn't find anything about the number of parameters, for example, because you can act on the layout of the slide. You can choose the size of the font, the color of the footer, this kind of thing. So I was wondering the number of parameters you can play with to produce this kind of size with all the variability you showed us.
Yes. So we have a probability system where we can you hear me well?
Yeah.
We have a probability system where we can influence on some parameters, right? So for example, we have a probability system that's influenced. The probability of appearance of the title. So first of all, you can have some slide without title, right? So we have this for a lot of elements. We have that for the titles, for header, footer, and then so this is like the probability system. And then the other parameters that we can play with are all the elements. So let me show you the slides. All the elements that we have on the style components, right? So we have the background color, we have the font size, the font that we use. So I tried to make realistic slides. So we didn't want to use parameters that make the slide very unusual or funky or stuff like that. So for example, we look at the slide data sets, and based on that, we tweak some parameters to make it so it looks like it. So when I'm saying tweak it, it's like, for example, the font size of the title will be between 30 to 40, 50 pixels. And for the color, it's the same. We looked at the distribution of colors of the slides, and you will see that most slides are white, but the background of slides would be white. So we just use our probability system to say, okay, that 70% of the slides that we generate should have a white background, and then 10% should be black, and then the 20% will be like different colors, such as light blue, light gray, something like that.
Okay. Okay, it means that if someone comes with a very special video lecture, maybe it won't fit exactly what you try to detect on this. Does it has an influence on what you detect on the slides or not?
So yeah, it does have it. Sorry, yeah, keep going.
Yeah, go ahead.
Well, yeah, if you have a very unusual slide, it might not work as well, for sure. We wanted to make it work mostly on like real slides. This was the goal. Of course, there will be some outliers. So there will be some very interesting slides. Maybe there will be slides with only images, and a mosaic of images. And we, of course, we couldn't make it sure that it would work on that type of slides. So we really choose to focus on some sort of like the general slides, like the templates that people might use on Google Slides, for example, or PowerPoint. We wanted to focus on that first. So I'm sure that we can also tweak it, so it can work. It could work on this type of video, this type of video or this type of slides. But we choose to mainly focus on on general, like how do you say that, the more common slide. You know?
Yes, I understand. And so when you generate different parts of the slides, are there some incoherence, for example, in some objects, for example, because you have to follow a special layout for the slide, so maybe sometimes you can have some overlap between the title and the image because as you add some random parameter or given some distribution. Okay, maybe you have this kind of problem. Did you detect that, or do you have some special rules to detect?
So yeah, actually we made sure that there was not what we can call overflowing. So because we generate like slides through HTML, we have access to the attributes. So we know that okay, this one is overflowing. So what we do is that we just stop the overflowing. So we make sure that all the elements doesn't overlap together, or don't overlap together. And I think we didn't make any. We don't generate slides that overlap. We don't have that where element overlap. And we make sure of that because the HTML, the tool that we had at the disposal to make sure that could make it work.
Okay. Yeah, but so I deepen my question because sometimes if you want, for example, to write something in a special color, okay, you have text in a special color, and you don't pay attention that this text is put in the background, in the same background color, for example.
Oh yes, okay, yeah.
Do you have this kind of rules, and I would like to know how you integrate all this? Is it on you play with some button and you try to resolve the problem, or you have a special rule before?
Oh yeah, we have a special rule.
Produce the slide.
Yes, we have a special rule. So because we influence on every type of data, we influence on the background, we know what background we put, and we know also what font color we put. So what we do is that we just compute. Since we know the background, we have a text of different color, we don't have the contrast. So we make it work. So we try to make sure that we have readable slides. Yeah, that's why we want to make sure that we have readable slides. And was first objective when we designed this tool. And the second one was to make sure that we make diverse slides that look like real slides. And so we make sure that we don't have, for example, white text on the white background. So when we have the black background, the text would be white and the opposite. So we have the rest of it.
But yeah, okay. But my question is, sorry to insist, just one question. How do you implement these rules? Do you have a special, sequential way to verify first the background because all you put in the background, and after that text, and after that you put the figures and you pay attention that the figure is not overlapping the text, the title, and so on. Is there a special, sequential way to do that, or is it just some rules that you put like that?
So there's a sequential. As we said, there's a sequential way of doing things. So when we construct a slide, we construct first like the root element. So the root element will be what font we will use, and also what will be the background. So we have the background, and then we look at what are the input content. So what we put as a text, and if we see that there's a lot of text, we pick a layout. So the rule is like, it's like, for example, if you have 5 bullet points, we will pick a layout that can display 3 columns, or at least 2 to 3 columns. 2 to 3 columns. And by doing that, sequentially, we make sure that we don't have elements that overlap together, and we have coherent slides. So first of all, so to answer the question, first the background is determined, and then the element that we put on it will be influenced by the background.
Okay, I understand. Okay, thank you. For studying the performance of the adding of the way you add specific slides in slide V2E and V.
Yes.
So you made some experiments to detect the objects. So I was wondering what was the intersection of our union value of this criterion to accept that this is correctly detected or not. What is the value you use for IU?
We use a 50. So we choose to use 50, 50 as IU to determine if it's correctly detected.
Sorry, I didn't.
We choose to use IU at 50 to determine if it's matching correctly.
Sorry, I don't understand. I'm sorry, but when you say that, for example, a part of the image is correctly detected at the right place, okay, you calculate the intersection of our union of the two boundary boxes, okay?
Yes.
And you accept as a good detection if the IU is bigger than a given threshold, for example. .9 or .8 or.
I was saying 50, but yes, it's 0.5.
Okay. Is it enough? Did you play with this?
Yeah, we played. So we had
to check the influence on the quality of the result, because if you are more strict, okay.
Yes. So I don't know if I show. We also explained with the common metrics like 0.5 to 0.95. And what we saw is that we also had improvements in this area. So right now I just choose to show maybe 50. I choose to show 50 because I mean you're right. I could have shown also 50, 95 as well. What we observe is that we have improvement everywhere.
Okay.
And
it was missing in the manuscript.
Yeah, but actually. We have also but because our CDN slides have perfect annotations, we do observe that the 95 has also a nice improvement as well. I may have forgot to put it in the manuscript.
Okay. I didn't see also in your presentation now, and neither in your manuscript, but I think it would have been good to have maybe a precise analysis of the performance per class of objects, because I think that for some objects maybe it's more difficult to detect than other, and do you have some ideas of what are the objects that are the most difficult to detect?
Yes.
and why?
So you're right. We also didn't put that, but I did the experiment. So let me just show you all the classes here. Yes. So we'll focus on cycle first, maybe. The most difficult one would have been caption, the caption level. So first, why? Because there's not a lot of captions in the dataset compared to all of them.
Okay.
And also, in this dataset, you can see that we have four different classes for text. Like we have object text, we have page text, we have caption, and then hollow text, and we also have So caption, the problem with caption is that he realized that when you caption relies heavily on the position, right? So caption will be detected, for example, when it's close to an image or something like that. But this is not always the case on all the images you see. Sometimes caption is a bit on the rise, etc., etc. So caption had the lowest performance. I think it was something like 0.2. 0.2. And then we have and for the most performing it has to be the titles because it's mostly at the top and it's big, right?
Okay.
And so all the visual levels, like such as table, diagram, image, figure, had quite like a high mean average precision. But yeah, I would say the text, except the title, the page text, had a lower performance. Like object text had a good enough, but you can see that it was hard to evaluate object text because most images didn't have object text in their ground truth. Yeah. So what we try to do is that we run experiments to try to balance the data sets.
Yeah, I saw that. But I think that what could have been nice in the manuscript is to show that you need to balance because you have this kind of drawback on some classes of objects. Okay, so you balance. Okay, to improve that. Okay, that's the way you should do. Okay, because you just balance in your manuscript. You say, okay, I balance. Okay, but you don't specify why you balance on some classes. So that's why but I understand. I can understand that there are some difficulties for some classes.
Okay. Yeah, you're right. It was an oversight of the and this is what motivated us actually to do that because there was an imbalance in classes. And that's why we tried to balance it. But you're right. I think it's forgotten the manuscript.
Okay, thank you. I was also wondering why you didn't make some quantitative evaluation of your segmentation mask. Because you say in your manuscript that you don't have any protocol to do that, but you have a manuscript, so you have data sets, so you can do that.
Yeah, so actually the problem is that these data sets provided like semantic segmentation in one. And I mean, the problem, yeah, actually you could have done that. But like the main problem is that when you look at the when you look at the way they annotate the segmentation task, it's really, it's like they use a brush to annotate.
Okay.
It's not fine. It's not very
yeah, okay. The way the annotation is provided is not precise.
Yeah, it's not precise. And since us we are doing I really for the text here, they would have they would just like pencil brush over the text.
Okay.
And yeah, because it's really precise, we think that it doesn't make sense to.
Okay. I understand. Thank you. About your, I moved to the temporal reality of segmentation. So I like the way you summarize the difference between the your system and data system. So you expand from, and I like the table for the form because you put exactly what you did differently from the time. And there is not always this kind of table in some manuscripts. So sometimes you wonder about what has been done exactly and what's different and so on. So I like this table, and I want to congratulate the society to put that in your manuscript. Thank you. I was wondering about the TW-Finch algorithm, okay? Because in your manuscript you didn't describe this algorithm so much, okay? You expect that people will read the paper, but yes, you didn't have to do that. So I didn't read the paper. But as there is some figures that are missing also, I was wondering how it works exactly from the hierarchical point of view. Because some segments are hierarchically attached to some other. Yes. So how do you manage that in practice?
So we have to first, since we want to evaluate against a ledger first, ledgers actually they know the number of clusters. So what it is that they use the refuge, and then they ask what they want about 6 clusters at the end. And so how we manage that is that we do the same thing as that we also put the branch truth numbers of chapters.
Okay.
To do that, right? And so how W-Fish works is that it constructs a graph where a weighted graph, and the distance to each node is this distance.
Okay. And so you plot in this graph.
Yes, exactly.
To isolate the classes of each hierarchy.
Yes.
Okay, to put the right level on the segment, right?
Yes. It's an iterative. It's an iterative, and then the aggregates merge the cluster of nodes together, and then it does the same again and again until it meets a certain threshold. But the threshold that we use here is the number of classes, the number of max clusters.
Okay, okay. And so I think that what also is missing in your presentation is a kind of confusion matrix between the objects or between the segments. Okay, because it seems that maybe for some figure we see that there is a strong a strong disagreement between the ground truth and your application. Okay, for example, I don't know if you have your entry, but on some figure you have a very for some nature of intellectual probability in evidence, but a very big difference between your result and the ground truth. So I was wondering if there was some segment that were especially confusing with other.
When you mean segments, you mean types?
Yeah, the type of segment. When you say, okay, this is a segment for introduction, this is a segment for chapter, and so on. Okay, between the ground truth, what is annotated, and what you present, sometimes you are well aligned with maybe 1 second before or after. Okay, we care about that. But sometimes you present something that is very not at all synchronized with the ground truth. So I was wondering if there was some quantitative measure of this confusion between the segments. Did you check that or?
So we didn't really check the way we just look at.
It means that you give an overall performance of what you are able to detect in the segments. Okay, but
yeah.
I think what is missing is that maybe some segments are more confusing with others than other segments. Did you check that? Just to look. No.
No, I'm not sure. We didn't check that. I think
No.
we need to check that.
No. Okay. 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 Because sometimes. I say okay, but no. Because in your video you have a very high number of segments. Okay, you try to saucisson. Okay, okay, make some tranche de saucisson. Okay, and so why do you have this kind of behavior on your system? Do you know that? No.
So you're saying, because I'm not sure I understand correctly. You're saying like when we have a high number of segments, you have lots of segments that might not overlap together.
Yeah.
And
yes.
we want to make sure that well, the first segments match the first.
Exactly, and maybe the set class of the segment.
What means class? So we mean, if they are together. So what we do is, I'm not sure if you answer your question, but so we try to match each segment with the one that fits the So for
Yeah,
example,
okay, I understand that.
so we do that, and then we then compute. So, but we don't have a matrix that say, okay, there was a lot of confusion. If that's what you said, we didn't quantify the number of mismatching. I would say, if I understood what you mean.
Okay. Yeah. Okay, but I didn't see about the. But I saw that in some in one figure in your manuscript, but I didn't see this figure on the side, so don't worry about that.
Yeah.
Okay. I was just wondering what is the robustness of your detection when the image is rotated. For example, you see what you are. For example, what you are. Here you are in front of your slides.
Yes.
Okay, and the image is rotated for, I don't know, maybe 25 degrees or something like that. Okay, so if you, for example, if you analyze this kind of video, are you able to retrieve the text and the image with this rotation, or?
So no, we didn't do any processing on the way. So this is like
Okay.
would be a good idea for future work, because as I said in the perspective, one thing we want to make it work is on the blackboard videos. On the blackboard, as you said, like there's also a lot of times. I mean, it depends on the video, but there's some times where the blackboard is angled at a different perspective. And this is something that we are working on right now, and we also want to apply that for slides. So actually, we also did, like at the beginning of my PhD, we was trying to align like the slide like this to get the transformation and to get the slide in the correct angle. We didn't really focus on that anymore. But the way we try to do is that we try to detect the corners of the projection.
Okay, also. I have just a last question because I don't want to take all the time. But so I like your chapter 5 about your toolkit. The way you can play with the videos, but I was wondering if you have the right to do that, because you take some videos from YouTube, so there is an intellectual property on the content. Okay. After that, you play with the video, and sometimes you can say, okay, I don't want to see the face of the presenter, so I want the image to be bigger. I want to put, maybe if I was very I don't know how English, but if I wanted to do some very bad things, I could introduce some error, and after that, download the video I have modified. So, do I have the right to do that? Did you take that to do some ideas about that? On that?
So, because actually, so we saw a work that was doing something like that, like hiding the commenter. And so we didn't really think about like, okay, we will really run into trouble if we do that. But also it's because I wasn't sure of, because since it's archive, I didn't think about like, okay, someone could download it after the modification and then do it again, right? But what I would say is that everyone can modify video. Like, I really did not think about this problem that you said, that you do. It is a problem, right? We just didn't think about
you agree that it could be.
Yes, it could be because.
Play with the video and to introduce maybe and to put it after that to upload on YouTube and say, okay, look at that guy, he's saying wrong thing, this is not a good figure because I am replaced by something else. So it can be dangerous, no?
Yeah, it can be dangerous for sure.
Yeah.
Because also I even okay, so there's a flow feature like we can actually modify the text directly. So you know I showed earlier like the translation, but it also means that someone can just modify the content into this. And yeah, you're right. So I agree.
Yeah. So I think you should be careful because okay, it can be used that way. I don't say that people are doing all that, always that, but it can be used that way. And you have an intellectual property on the content, so you cannot do what you want.
Yes, right.
Okay? So please be careful about that.
Yeah, yeah.
Okay. So it was just my last question. I congratulate once more about your presentation and your manuscript.
Thank you.
And thank you for letting me discuss and asking for questions for half an hour. Sorry.
Thank you.
Thank you. So we'll ask now the second reviewer, Munir Eliakoubi, to ask some questions. Thanks a lot.
Thank you, Geraldine, Mrs. President. Do you hear me quite well?
Yes, very well.
Great. So first of all, I would like to thank the supervisors, so Alex and Uwe, for inviting me to take part in the jury and to serve as a reviewer. And I'd like to congratulate you, Davis, for your nice presentation, well illustrated with nice figures, but also good structure in terms of logical presentation, always talking about the context and the state of the art, some kind of limitation, and how you position your work. So this is much appreciated, and actually it's quite in line with your manuscript, which I really liked. It was well written, technically sound, and quite easy to read for me. In terms of the manuscript, I liked, so I put in my report, so I liked the state of the art that you have written, especially regarding the deep learning part. I think it was really, you took it from a historical perspective, talking about how machine learning has evolved with, from basic machine learning to deep learning, the transformer attention, which led at the end to LLM at each time, showing how each new model built upon the previous one to improve it, leading to what we are seeing right now in the LLM era. So I put it also in my report, so I found that transition to what you have proposed was quite fast. I didn't spend much time to explain why current LLMs cannot handle the task that you want to do, and which for sure they can't, but maybe they can do some and not the other, and why. But we will return to this at the end, so I don't want to start with this. So I think Laurent didn't leave any room for questions to me, so basically ask all the questions. So thank you for your kindness, Laurent, so I don't have much work to do. So what I will try to do, so I will try not to go into the footsteps of Laurent to avoid overlapping questions. And to start, I would like to go back to the basics, actually. So you start this thesis and you are basically overwhelmed with the type of the data that you have. You have like video that can last 45 minutes, I don't know. You have a lot of modalities, etc. So you have a huge amount of data. And the first thing you might ask beyond the models is how you are going to process the data. So first thing is just regarding the spatial temporal resolution. Did you do some study on that? Whether maybe you need just to process few frames per second, not the normal frame rate of 24 or 30 frames. Same thing in terms of spatial resolution. Maybe you can downscale the resolution. I don't know, this is a question. Did you ask yourself whether you need to process the raw data or maybe you can just downscale the resolution, and how this will impact the processing time? So you mean for every video, you mean the entire video? Yeah, so just to give an example, for example, the current visual language models, most of them don't process every frame. So for example, they want to do like kind of a dense captioning, but they don't process just some few frames per second. So And especially in your case, because you have like video lectures, so these are quite a large duration. So did you do some analysis? What is the minimum resolution, both temporary and spatially, that will allow you to do your work in a precise way?
Yes. Oh. So obviously we've done what we know that LLMs are quite heavy, right, in computer power. So we try to position our work as a way to let's say that, make it like way easier and lighter to process videos. So that's why we didn't want to write too much on LLM at first, and we just wanted to use more traditional tools, I would say.
Actually, just if I may, right now I will talk about LLM at the end. Right now, my question is not regarding to LLM.
Yeah, so
Just what you have said, what you have done in terms of spatial and temporal resolution.
So
how do we know? Maybe you don't know the full resolution that you have in your video. Maybe you need just lower resolution, and still you can apply the same algorithm that you have done without losing much accuracy.
So we did. So we wanted to have like fast processing, right? So what we did is that I tried to use as less resolution, spatial resolution, and temporal resolution as needed. So for example, for the temporal one, we didn't think that using all the frames was necessary because there's no.
Excusez-moi. Et une soutenance de test, c'est possible de venir après parce que
On nous a demandé d'allumer la clim en fait.
Ah, d'accord. Ça marche. Merci.
On va si vous voulez.
Pas de soucis. Non.
Désolé,
Est-ce qu'on peut faire une petite pause alors? Merci beaucoup.
excusez-nous.
Pas de soucis.
So we didn't think of using all the temporal resolution because we didn't think about using. We think about using all the frames, but it didn't really make sense because, for example, on slide video that are really structured, right? There's little like changes. So that's why we wanted to first detect all the slide cuts, and then we want to work on that. So right now I'm talking about the slide-based videos. And you see on the Blackboard videos, they have way more information because the projector is writing. So here we try to use more frames. But what we use as a baseline is basically one frame, 1 second. We took one frame each second, and I try to experiment with more. But for example, when we detect the scenes, right, we want to take the transition since we want it to be like quite precise, at a second tolerance. That's why we stay at 1 second. So this is for the temporal.
Okay.
This is for temporal, and for the spatial one. So obviously you can see that on some of the slides, like sometimes the writing is really small. So we try to keep the resolution of the slide as it is. Almost every time, but also since we are using models that don't scale internally to 640 by 640, and so it worked quite well already. So, but we didn't really try to downscale the slide any image.
Maybe it's worth to try because just because of the heavy processing time that you have. So at the opposite. From all the algorithm that you have applied, did you realize that there are some object or something that would require larger resolution that you have right now, or the normal resolution that you have are quite sufficient to do everything?
So
you understand?
Yeah, I understand.
So if you have like 30 frames per second and the size of the image are all okay, or maybe for some tasks, I don't know, they would require even more precise resolution?
So, I mean, for the slides, since I'm using the slide directly when I have access, I didn't really find anything. In terms of the spatial thing, right? In terms of spatial domain. But for the temporal, obviously, if you want to make it, so for example, there's some videos where the cursor is moving and the camera is moving as well. You know? And so it is especially present in all the data sets of that I showed in the temporal segmentation part. And here, what we want to do at some point is that we want to be able to track the blackboard because the blackboard is moving, the camera is moving. And so the blackboard is not always shown, right? Sometimes you have some part of the blackboard is shown, sometimes the printer is going in front of it. And we did find that having a more precise time temporal resolution helped because it's easier to track and you have access to more frames for sure. So for this, yeah, I would say we need some.
Yeah, regarding slide dataset generation, so I think I have a couple of questions. So first, the first one is regarding slide imbalance, data imbalance. So right now you work only on slides. There is no handwriting, or there are some handwriting in it, the ones that you have generated.
So yeah, so we have, I don't know if you see here we have equations and then we have writing.
Yeah, so my question is related to the, so the slide, so you try to balance all the types of when you generate, right? But actually, not all the slides have the same difficulty, the same complexity in terms of, let's say, recognition or whatever. If you have just static images with nice or text, right, this is easier to handle, to process, whether recognition or something else, than handwriting. So maybe in terms of generation, you need to take into account the complexity of the slide. So for example, handwriting would require something like maybe 3 or 4 times the amount of data that would require just some text, because it's not the same complexity, and you need more in terms of training, right?
Okay. Yeah. So yeah, actually.
Maybe you yeah, I think it's good what you have done, but because you did a lot of things, but maybe you can adapt your this kind of generation, which we try to handle the imbalance, but also by taking into account the complexity of each type of slides. You see, so that would be ideal. Just kind of adaptation. So you need to design some way of assessing the complexity, which will give you an idea of the amount of data that you need for that setup, right?
So in some sense, it's like a Seng benchmark. So then you try to project more and more value to make sure that you attain a certain amount. Yeah, certain performance. Okay. Yeah, I do agree. And that's something that we didn't reconsider, and I think it's a great idea. Because we thought that we didn't take account of the complexity. And then we just felt that by just balancing the labels, it will work. But yeah, you're right.
I think what you did is great. You need to start somewhere, but it can be taken as some baseline and then to go further, etc. So in the same way, actually, so you talk about blackboard, handwriting, etc. And even for the speaker, you know, this task is quite different. So it has a lot of similarity, like with the speech data, handwriting data, movement data. But here you have, for let's say, if we talk about speech and handwriting, you have the distance effect, right? So it's not like you have a handwriting detector directly on the screen. If somebody is writing on the blackboard, there is the effect of distance, right? And if the handwriting is quite distant, so the resolution means it will be lower, and it becomes much more difficult if it is closer. So, and this related to my first question regarding resolution, because it will depend. So if you have the writing, the slide is quite close, so maybe the current resolution that you have is quite enough. But if it is far away, maybe you need higher resolution, or you device some kind of super resolution before doing things. And if I talk about speech, same thing. So maybe you have the person is a little bit far from the slides. They can be close away. And maybe you need to, so this variation might make the task more complex, and you need to take into account whether training on data generation and so on. Yeah. Yeah, this is just a remark. So I'm just saying that this task make your job a little more difficult. Just conversion as speech recognition for when, especially if there is a microphone. So here you have the distance effect. Sometimes the person is maybe they have a microphone, maybe they have not, etc. Same thing for handwriting. So it's not like we have it in directly and the resolution is okay. Other than that, actually, your task is what you have done is based on using several existing tools like Whisper for speech recognition. You have done also video type recognition. Like, is it a slide? Is it don't know, was it a blackboard, was it handwriting? I just have a simple question. Did you assess how good they are, this kind of, whether, for example, for Whisper, do you have an idea whether it's just perfect or it does make some mistakes and how this will affect your overall framework?
I checked.
Because you don't have annotations, right? So I mean, I'm talking about
Yeah,
video.
so we
You
don't
don't
have
have,
annotations.
it makes evaluation harder.
And
But maybe if you have just an idea whether you are 95% correct or what is the error rate, just maybe you can take into account in some way. I
so,
don't know.
so because we didn't have annotation, so we mostly did qualitative like evaluation by myself. Is that I tried to listen and see for the complex part if it was correctly detected. And as I said, actually it was good, but obviously there will be some mistakes. And of course, it will impact the final performance of the segmentation. And this is the same way as the OCR. So so for example, the aviators, the dataset of aviators do provide the OCR for each video from the dataset. So I was saying, they have 350 videos, and they actually run an OCR algorithm, actually even like a commercial OCR. So we just use that as a baseline to make sure that we were using the same information at our disposal. But for sure, when we look at the way they do their OCR result, you will see that on this kind of pictures, you will see that on this kind of writing, it would work very badly sometimes. And so, yeah, obviously, and I think I was saying it in the manuscript, is that if we have better OCR or better OCR on the blackboard, we will have better performance, because sometimes the OCR on this type of on this image are almost nonsense. And I think you were mentioning also my classification algorithm, this one, right, the video type classification. So actually, I didn't put enumeration, but we did do qualitative, a quantitative evaluation. So yeah, and it was I think we did do a quantitative evaluation for that, and we had almost 100%, 99% of correct classification.
Let me get to the second contribution. So try to segment the videos, the lecture into segments, right?
Yes.
And I just saw you want to detect the short boundaries. And my question, what is the most important thing for me for you to detect? So there are like appearance changes, right, in the video frames, and there are semantic changes, right, depending on the content. And sometimes you might have sufficient change in the frames, but still the semantics are pretty similar, and you are still in the same segments. So, what are your thoughts regarding this?
So, so obviously we run a transition detection, and of course this transition detection is more based on appearance for sure. So sorry,
Based on what you said?
on appearance.
Ah, okay,
sure.
okay.
Yeah, for sure.
So, yeah.
But
And
since we
you don't observe sometimes that there are some significant change in terms of appearance, but still in terms of semantic of content, you still have the same segment.
you mean so you mean like sometimes like there's not
Let
a
me give you an example. You have the same shot, the same segment, but at some point you have a different view, maybe a different camera, right? But still exactly the same content. And because of the different view, the appearance have changed a lot, right? But still,
okay.
normally you want to keep this all this frame within the same segment. But if you base your segmentation on appearance, you will split this segment into several parts, right?
Yeah. So yeah, we did think about that. Like for example, how do you say that? For example, if this was so we did think about that. Sometimes you can have two different slides that doesn't look the same but speak about the same thing. That's what you're saying, in a sense. So that's why we wanted to rely on the embeddings because we thought that the embeddings would be closer, and then so it wouldn't make a lot of change.
Yeah.
But also, yeah. No, I guess that's it. Yeah, we were just we're just thinking that the embedding comparison will be really close between the semantic.
Okay.
And
I
even
see.
the OCR, right? Yeah.
Yeah, maybe if you combine both the appearance side, but also the embedding that are trained to
Exactly.
infer content semantics that can give you more clue whether really you have a real change or that was just change due to lighting or something, right?
Yeah.
Okay. Um, yeah, I have a question regarding the result that you have shown both on slide 30, no, 45 and one previously, and 28. So I see the results are not that high. So both in both slides. So I do see improvement from your contribution. That's not the question. So with respect to the same baseline, but overall, whether the baseline goals are not that high. What is the main issue that you have here, whether in this slide or in 45, that make the models not able to be close to 90%? Let's say. What are the main type of complexities for this kind of all the models that have are developed in the state of the art, including yours, prevent them from reaching very high accuracies?
So I think first is all the type of annotation, right? So if we go to the slide where I show the different classes in Seng, we can see that there's like 4, even 5 annotations that are actually the text, right? So for example, there's like caption and alt text could look similar, or caption and page text could look similar. And obviously, since they're very similar, even in position they can look similar, right? Sometimes the caption sometimes here, for example, it could have been not a caption but something else, like a page text. And I think it comes from this confusion that a lot of classes look similar, a lot of labels look very similar. And the same way as we have the same way for the image figure diagram, right? What is the diagram? What is the image? It's quite, sometimes it's quite hard to differentiate them. And it was really in the FitVid dataset, they had actually two labels that were called, there was one called diagram and another one called schematic diagram. And actually, it was hard to find the difference between them. And all of this, I think, make it harder to, I mean, all of these are the issues, I think, about why it's hard to get a high performance. I would say that if, for example, you have less labels, like only title, page text, and an image, obviously you will have a way bigger performance. And I think to fix it, yeah, we need more data. So that's why we propose that thing. Okay. But I think there might be a work to do on the labels, for sure, on the classes. And there was also a motivation, so that why we designed a tool that can allow you to customize the classes. Well, that's why we did that.
Okay, sounds good. Yeah, if you maybe I'll finish, but a couple of questions. One over regarding the LLM. So I think you have put a slide on the perspectives, right? Yeah, when basically you.
Yeah.
Yeah, I mean, maybe there was another slide before, I don't know, but anyway, it's okay. Yeah, just this, I put this in my report. Yeah, I found it that you passed quite quickly from talking about the state of the art to your own contribution, and you didn't spend enough time to discuss why you're just using LLM as the art. Let's say, for example, GPT-4 with the vision modalities and multimodal LLM in general. What they couldn't do until like a few months ago, and when you submitted your thesis, the report, and now because you know it's the pace of improvement is quite fast. Maybe it's not exponential, but it's not linear. It's non-linear. So what they couldn't do and what they can't do today, or what they can do today that they couldn't. So I mean, like for example, just slide generation, like you did just. So whether it's in zero shot, only few shots, right? So in zero shot is more complex, but maybe if you give us some few examples, so, okay, and
yeah,
can they do the task for you or not, and why?
So yeah, so for example, it depends. But like, if you're talking about slide generation, so obviously now you can directly use the LLM to almost generate like the plan for you and the bullet points. So we use, for sure, we use Wikipedia as a source. And I think at the time when we published that, LLM was not as good as now, right? But nowadays we can directly just input the prompt, just like give me a slide, write me a slide of 20 presentation of 20 slides, and it will surely give it to you.
So they are pretty capable now to do it, right?
They would be pretty cool to do the content part, right? But then you will need to style it. But actually, I even saw some work where now you can directly ask them to generate the HTML for you.
So even the style, right?
Sorry?
Even the style of the slide that you want,
yeah,
right?
you can do that.
But
so,
I'm sure maybe there are still limitations, and do you know some like limitations that they cannot do today? They still cannot do.
What they cannot do.
I'm not talking about slide generation, but even on the second contribution that you have shown.
Yeah, on the second contribution, obviously.
I'm sure they are not perfect. They still have some problems, but I'm just curious which ones are they could do easily and which tasks they still have trouble to do.
So we do so for this task of recommendation, we did try to ask an LLM to segment a video. So the most common problem is that they tend to over-segment, and also the size of the video makes it hard. I mean, the size of the transcript make it hard to fit everything in the context. But now the context grow larger and larger for sure. The thing is that not everyone have access to like GPUs, processing power. So that's why we wanted to not rely on this, but for sure, like every day, every week, there's a new there's a new model that is smaller and works better, right? So obviously, but right now the first, maybe the main issue is the context size and the way that it tends to oversegment. So that's why we are trying to see with what fine tuning could do, right? So we did experiment with fine tuning actually. I have a result on fine-tuning an LM to do the temporal segmentation. So this is not in the manuscript, right? See, just like because like LLM research is growing so fast, so we wanted to try some things that. So we were inspired by this paper that tries to fine-tune an LLM by using the transcript. Except that we try to input the modalities. For example, every time we detect a new slide, we know what is the OCR. And then so we say, for example, okay, at 37 minutes, there's a new slide. And then there's the rest of the speech, right? And, yeah, we did observe some good improvements just by doing that, just by using more modalities. But this is something that we're still exploring. So it's still very... Yeah, and you can see that zero shot, for example, doesn't do as well. And and few shot, if you were to do few shot, then it means that you need to give a lot of examples, some examples at least, and it would be harder to fit the context.
So how many? Sorry, you are talking about few shots.
So we didn't experiment with few shot, right? But if we're doing few shots, maybe you will have less context size available. I would say. But maybe 1 year, maybe it wouldn't be a problem. I don't know. But right now, we did experiment with that. And yeah, this is something that we're still exploring. Yeah.
It's good that you tried. Yeah, good.
Yeah.
So there's some potential. Maybe I'll finish about the interface.
Yes.
Just because you talked about neurodivergent people in the manuscript. Neurodivergent. So how
Yes.
do you, in which way, so did you try with some neurodivergent people? Who are they?
Yes.
And did they try the interface? What do they think about it? So
we are working in this lab, in same lab. We are working. There's a colleague that is working with. His name Damien Guillotin. He's working with neurodivergent users. So he's working with also psychologists, and it's with an association called ATP Friendly. And so he did show my work, this interface to some neurodivergent users to know what to get the feedback. And yeah, so it was a psychologist running the interface with some of neurodivergent users.
But the interface is intended to be as is, or it will be adapted to neurodivergent.
So it will be adapted, right? So there were some things that we implemented based on the feedback, but we didn't run. But there's still more to do, right? There's still more study to do. And this is a future work that we plan to do, like to do a full study, user study with neurodivergent users.
That's great, really great to have tried this. That you are working on this. I think it's very important. So I want to congratulate you again for your work. So please stop here. Thank you.
Thank you. Thank you very much.
Sorry, I don't have the image anymore. One modality that is audio. So thank you for your questions, and Maria is listening to.
So first of all, I would like to thank your PhD directors and supervisors, and especially Axel Carlier and Vincent Charvilla, and also Professor Oy for inviting me and participating to your jury, because I found your work very interesting. I really like reading the manuscript, which is well structured, easy to follow and read, which all the both reviewers said already. And also I like the original interactive way of presenting the slides, so one can see that you've been working on those lectures, and you know how to catch the audience attention. And just a few things that I really liked about the manuscript itself is the state of the art, especially about the transformers, which was pointed out already by Professor Al-Yacoubi. Personally, I was very interested in your work in chapter 3, probably because I previously worked in an ANER project about generating historical documents also. So I'll have a few questions about this. And also in chapter 4, so you inspired from another approach, and you recap your changes to your approach in a table which Laurent Heut already referred to, and I already wrote that beforehand. So this is something that was not in the slides, but it's a good thing to say, because it's not very often the case that we have such information. And regarding the toolkit, I found it very interesting that you already try to adapt to neurodiverse people, taking into account their feedback. So now I'm going to start with my questions, first about chapter 3. So if you go to slide 26, yeah. Here you have some examples of generated slides, and what we don't see from these examples, but from what I understood from the manuscript, is that you take the textual, tell me if I'm wrong, you take the textual information from Wikipedia, and then you take the graphical information, equation, etc. from different datasets. So when you get the slides, they might not be coherent in terms of content. Is that right?
It's right.
Yeah, okay. So this is probably why your slide generator is only useful for training in the context of object detection, right? And that's probably why you can't go much further with this. So I was wondering, if there would be, if you could think of any way to try to force the content to be coherent through the slide.
So, I mean, if we were not using the external datasets, then it will be coherent, right? So this is the first thing we could do. So on maybe, yeah, on this slide on the bottom, for example, you can see that it's mostly images from the Wikipedia articles, because we do fetch the Wikipedia articles. And yes, the problem is that sometimes we wanted to have more diversity of images, right? For example, the problem with Wikipedia images is that they are not really annotated. It's that we don't know that this is a diagram, this is, I don't know, a figure or chart. And so that's why we rely on external datasets to make sure that when we include a diagram, we know it's a diagram because it comes from diagram datasets. So one way to force that would be to only use Wikipedia images. But then another way would be to maybe do a search query of, I mean, when you put an image, what you do maybe is like you try to find a relevant image to this slide instead of just using a random generated, random content. So we thought about that, but since we were focusing on object detection, we just add like whatever we had as a dataset. And another way we could do now is that we can also generate images. For example, we can say that, okay, we want an image of a graph that explains this slide, and then we can just like generate it now with the tools. The problem is that it takes time, and it can hallucinate. And sometimes if you need a text on it, sometimes the text looks very weird. I don't know if I have an example, but I mean, I'm sure you tried generating a diagram, and maybe like the text doesn't mean anything. Yeah.
So your textual information, you take it from Wikipedia, and if I understand correctly, you don't take the diagrams from Wikipedia because also you don't have enough in Wikipedia.
Yes.
It's not a lot of illustrations in general, but did you think of maybe scraping a scientific article data set to have more tables and figures, at least with 2 classes?
So we do scrapped other data sets to add more diversity, but the thing is that since the problem, maybe limit of what we do is that we just use random Wikipedia from random Wikipedia articles, and so it's hard to find specific diagram that fits the content. I mean that, that, how do you say that? That is coherent with the slide that we want to generate.
That's why I was suggesting maybe from scientific papers.
Oh, yeah,
because then you're sure that it's coherent between the text and the...
So you're using the paper as the source?
Yeah, exactly. For both the diagrams, figures, tables, and the text.
Oh, you're right, yeah. So we didn't explore that. And I think it's a great suggestion to make it more coherent.
You wouldn't have probably the subclasses like the diagram, whatever.
Schematic diagram.
Yes, this kind of schematic diagrams or this kind of things, but maybe something to...
Yeah, we will have like maybe diagram, figures. I mean, the thing is that because we wanted to evaluate on these data sets, we needed to find a way to have the annotation beforehand. Like, we wanted to find a short data set or a figure data set. And actually, even like figure and that's a short, sometimes it's hard to, it can be confusing, right? Like, like the labels, sometimes the labels are not really coherent because, as I told earlier, there's a lot of there's schematic diagram and diagram. And then figure can mean a lot of things, actually. So that's why it was hard for us to find an external data set to be able to, that fit all the classes for evaluation.
But if you are stuck with this problem, then your synthetic data set can only serve for enhancing the training phase of an object detector from slides, right?
Yes.
And in that case, I'm wondering if it's really useful to generate the content itself. If you couldn't just oversample in the feature space with some technique like SMOT or ADASIN, or did you try those as a comparison?
No, we just use Wikipedia and...
No, what I mean is that here you're generating slides.
Yes.
You're generating synthetic slides so as to oversample your minority classes.
Yes.
Let's say caption, for instance. So there are other techniques that do not work in the representation space, but work in the feature space, so as to oversample some minority classes. One can cite SMOT, ADASIN. There are many variants of this. Did you actually try to compare your results in terms of enhancement of object detection evaluation towards methods of oversampling that work in the feature space?
No, we didn't do that. I think I wasn't really aware of such techniques, so that's why we didn't try that.
It might be something to look at because...
It's so interesting. I think it can work. I think it can work. It's worth spreading for sure.
Yeah, the slides are very interesting, and it would be good also to augment them with video or transcript that fits, etc. But I'm sure that you have many ideas about using generative AI for this.
Yes. So we even thought about generating like a whole lecture in a sense now, and so at some point, and we limited by maybe like the power that we have. But we wanted to do like whole lectures with and then we can also generate like the chapters, and then get fit into the second contribution. So now you have synthetic data to supervise training. Yeah, so we did think that this tool could be improved and extended more to generate like whole lectures.
Yeah, and then it would be interesting compared to the feature space. But at this stage, I think it would be interesting to compare with oversampling at the feature space, just out of curiosity.
Yeah, it's a good idea.
And also about evaluation, the question was already asked by Professor El-Yakubi, but I think you have some, in slide 19, 20, something around this one. 19, maybe. Yeah. Here. So, so the performance evaluation is not very good, but at the same time, you say that the ground truth is not very good, right?
Yes.
So this is a problem. So when you are generating your perfect synthetic data, you kind of partly fix this for training, but this kind of ground truth annotation problem still poses a bias in your learning process as well as in your evaluation process. So do you have any idea how to fix this?
So to fix this, so what we could do is that what we could have done is that we could try to predict after we learn on the augmented dataset. We can try to predict again, and then we can look at the slides where there's the most where's the precision really low, and then we can maybe have done a filtering to remove this kind of thing. So there was, this is one problem, but then also we need something to annotate more, right? So so either we could do filtering or we could do re-annotating.
Yeah, like putting the human.
Yes, exactly. The thing is that it's quite tedious for slides, but annotating is tedious, like overall. But we did think about that, trying to re-annotate, but we wanted to, I guess we didn't, so we thought about that, we didn't explore that too much. Like we just explained why it wasn't working very well, like the annotation. But yeah, I do think that we could have filtered the training set and also the test set for sure to have a way more accurate and reliable evaluation.
There is no work in the literature, but I'm not working on this kind of videos. There is no work in the literature where they try to solve this problem from this data set.
So
everybody's working with this ground truth.
Yes, the thing is that there's only 4 datasets, and I don't think a lot of people are using even this dataset. I mean, this dataset actually is quoted a lot. It's like quoted like 80 times, but most papers just said that, just quote it. Don't really use the dataset. They just quote it as work on dataset labeling, and because they also do visual question analysis as a other task. And I think this is the thing that is more quoted, cited, maybe. Yeah, and that was the problem, for sure. There's not a lot of state work on this kind of data sets. So that's why we wanted to at least provide a tool to generate synthetic human.
If you go to slide 39, I think.
Yes.
So I couldn't see, if I may have one remark on the manuscript and the presentation, is that you generally don't give a figure giving an overview of the whole pipeline of what you're doing. So if I understand correctly, what you present here is the first step of a sequential approach. So first, you classify your presentation into 3 classes, slide, blackboard, or over. And then you apply OCR if it's slide, or more refined handwriting recognition if it's blackboard.
Yes, exactly.
Yeah, and in the manuscript you showed an example where a video was actually misclassified as a slide, even though it was a blackboard.
Yes.
And this led to a huge drop
Yes.
in the temporal segmentation. So I was wondering if you already considered the fact of maybe returning, not being fully sequential, but maybe returning to the first step in case you detect some problems, or because also in the manuscript you say that you didn't evaluate this first step of classification.
So yeah, we didn't evaluate on the new datasets, but we did evaluate on another dataset. Yeah,
Okay.
but yeah, the dataset we didn't say that we were 100% correct.
Mm-hmm.
Yeah, true. So we thought. So we actually we didn't really thought about going back. We just thought that even though it's classified as slides, maybe it could work, but it didn't, right? So I think it's just like a limit of our system is that sometimes there's a lot of noise. For example, on this video, there was a lot of like a visual analysis detected as a slide because they were like handwriting that looks like text like on the slides. And obviously it's limits. We didn't, how do I say that? Since it's true that we use the detection of the video type as a first step, it can lead to some errors. And I think in the dataset, what we did is that, okay, there's some errors that can explain by that, but we were thinking that maybe it would still work, you know, but we're sure that it doesn't.
In your system, do you have any way to detect that there might have been a problem at the first step?
Actually, I don't think so. We don't have it because this is the only time we do analysis. We do like visual analysis, and then if this step says that okay, it's supposed to be a blackboard or a slide, then we just think there's no way to recover that in our pipeline.
And I don't know if the visual information never really aligns with a transcript, you know,
Yeah.
isn't there any way to...
So, I mean,
Oh, okay. There might have been a mistake somewhere.
yeah. So, I mean, even if it's a slide, we will still run OCR or anything. So at the end, so the only difference at the end is like whether or not we use transition actually, compared to Blackboard. So the thing is that if we don't find any transition, then it doesn't really affect the pipeline. But I would say, but we show that the results are not good. But we also think it's that because the video that was only detected was really low resolution actually, and that OCR was really bad. I think it was I don't know if we talked about the same video, but it was a video where someone was writing on some sort of transparent screen, and it was detected as a slide. And I think the main error here was due to the OCR extraction. And obviously this is a big component of our pipeline. And you're right, it would be good to see if we could say that, okay, this OCR is bad and have ways to know that it's bad.
So that you can focus more on
Yeah, exactly.
transcript, for instance.
Yeah. So we did also think about having at some point we did think about having a weighted approach, like you put more weights into the transcript or visuals, and we even wanted to have some sort of like semi-supervised where you learn the weighted depending on the video, but we didn't make it work, and I think it's because we don't have a lot of data actually. But yeah, it was worth exploring, and yeah, there's actually a lot of things we could improve And yeah, but some video we use actually has a very low resolution, and I think it's responsible for a lot of low performance in OCR and then low performance overall.
Maybe if I may, just one last question. So something you explained in the manuscript, and you also said it again in response to one of Professor Eudes' questions. You assume, in order to compare with the state of the art, you assume that you know the number of clusters to be found in the video.
Yes.
And I understand that, of course, because the original work was doing this, you have to do it for a fair comparison. But I just like Laurent, I'm not very. I don't know very well the TW Finch approach. Is there any way to automatically set the number of cluster?
Yes. So if you don't define any number of clusters, it would just stop where it would just stop at the number of clusters where the distance is. There's a distance between the group or too high. It's too much, but this is like arbitrary.
Like in a dendrogram.
Yes. The thing we could think about is like finding ways to determine that number of clusters automatically. So we could use, like, for example, the variance between the cluster or inside the cluster. So we do think about that approach. And also, now that since it's a hierarchical, you can just look at the hierarchical and have the dendrogram. So you can have, for example, the first two sections and then subsection, etc. So you could do it, just that I didn't really mention there because we wanted to compare with the ground truth. But I also see that, I also think that since we couldn't directly determine an optimal number of clusters, because maybe the end of the what I mean, like the final cluster that it will give you, maybe there's too many clusters. So that's why the hierarchical approach is a good way to find it. But another way to fix that would be to do some supervised learning, right, where you learn directly the boundaries of your data. So that's why, with that, we are trying also to compare with the approach I showed you earlier with the LLM fine-tuning to see, because when you supervise, you don't have to precise a number of clusters. So we want to see how well we can compare and if we can find the same boundaries with these two techniques. And yeah, so this is something that we want to explore for sure.
So I'm done with my questions. Thank you very much for your nice presentation and answers.
Okay. Thanks a lot. So thanks to the external member of the jury. I'm going to just talk a little bit before letting the people that have advised you give their words as well. So I want to join the viewers and examiner for the nice manuscript. I want also, because I've not been following you at all, but you have been in the lab and in the team, and it's a PhD in deep learning. It's very hard to follow the changes and the dynamicity of this field. And I think you have been really an example on that, to stay on top of the wave and keep surfing on the new tools and the new performances. That was also a little bit the question of Professor Yacoubi, and you have been doing new things with the. So that's really great, and also I want to point out the hands-on quality of your PhD, because you have been not only developing things, but also in a very extended way with tools, and it's very exciting to follow up and to know what is going to come out of that. So thanks for that. I have a little question. It was raised that then you open this field to adaptation, to like Damien is going to do, to people that have a different way of learning. And I was you also answered the question saying that you stay with a density of probability of slides that is just commonplace. There is this work, or there have been this early work in deep learning, like I want to paint like Van Gogh. So I give you a pedagogic material, and I want to teach like one of my colleagues that you have some, like I want to teach like a professor in MIT. You have a lot of videos like that. And could you change the density of probability of the content you have been analyzing to match the style of the teaching? You know, could you imagine that?
So this is something that we actually explore a bit. Just so now that we can actually analyze all of the elements, we can. I mean, by style, you mean the style of the presentation, right?
Mm-hmm.
So what we could do is that we can actually extract the template of each of a presentation. So obviously, with the tool, the synthetic slide generator, you couldn't write your slide in the same way, but you can have the same template. If
Can you say, for example, my slides are too heavy, like I have too much text, or you know, like the text part is too heavy, and I need to do something that is more sparse, less dense.
So we do have guidelines about how to make like good slides. So these guidelines were studied by like some application I showed you, right? They were saying like, okay, on the slide you shouldn't have put too much text, and they go even further. They say, okay, they tell you, okay, you should have a text that is at least 20 pixels, something like that. So we try to follow these guidelines, and what we are doing is that, and there was something that in the plan, there was something planned that you could generate the slides, but in a good way. I mean, a good way, just respecting these guidelines with our tool. And this is something that is almost a feature, but I mean, that was in the plan, for sure.
And so I'm always thinking about 3D, so I give you a 3D content that maybe you are virtually going through. And can you imagine doing the same kind of work, so analyzing what I want maybe at the end is a scene graph or like places of interest. Could you imagine applying you have been like temporarily structuring the content of the video and doing some multimodal analysis? Do you think it could be applied in some other content, like a 3D scene with some semantic and some
I guess, I mean, you mean like any contribution I made? Like anything, if I could apply anything I've done to other domains?
Yeah.
I mean, I know that, for example, synthetic data generation is a huge topic.
Yes, that's right. It would be like, I think it could be used like this, like you provide the analysis of a given scene, of Mario World, for example, and you can resynthesize them like.
Yeah, I think maybe that has been done. I think obviously like if you detect all the elements, then you can just like move it, right? I'm not sure I really understand your question. Do you mean like can we apply
like for example, you have this temporal dimension, and you structure your video against chapter. So there is this 3D world, and I want to structure like in a scene graph, you know.
I think that we can use it if you have like a 3D scene. You could analyze different modalities, obviously in different way that I do. You can even like, I mean, as long as you, how do you say that? By analyzing all the modalities in 3D, I'm thinking. I think for sure, yeah, you can, because now you can even use LLM to tell you, okay, now that I can see, right, you can split the scene into different types. So you might use LLM or something else like object detection on the 3D scenes. And I think actually this pipeline can be applicable, yeah, to a lot of other domains, as long as you can yeah, as long as you have managed to extract something from all the modalities that you have. So since I'm not too into 3D, I'm not, but I'm sure like there's a lot of things we can extract. Yeah.
Multimodality framework.
Yeah. That's right. Yeah. I think this multimodality framework is applicable to any domain, I guess. So this one we applied on video, especially video lectures, but obviously on videos, normal video it could be done. The thing is that video lectures is quite structured already, so that's why it's easier to extract a structure out of it, and it's also visually visual. So obviously that's why we run an object detection algorithm on it. So as long as I guess in the 3D world, there's a lot of visual thing, I think we can do something with it.
Okay. So yeah, my last comment, and that's not a question, is as the head of the team here, I also want to thank you for all the help you provided. So you helped me with teaching the AI lab for sure. I think you have an amazing understanding, a deep understanding in deep learning. So that's really cool, and you really helped other people with your making things run, and so you also made help us to answer email by providing us a little tool to automatically answer emails. Thank you for that. And now I'm going to leave the floor to the people that have advised you during your PhD, and maybe we start with Wei Song, because it's late.
It's very quite late.
Hi everyone. Can you hear me well? Oh, yeah. So thank you, Travis, for the nice presentation and for inviting me to attend this defense. It's been a pleasure working with you, and I just want to share my working experience with Travis. In the presentation today, you see a lot of like experimental results, right? There's actually a lot of work that went into getting the results to that stage. And some of my students, when they come to the weekly meeting and present the results, they usually just tell me the numbers. So I improved this by this much, right? But what Travis usually do during the weekly meetings, he doesn't start with the things that works. He will start with things that doesn't work, right? So he'll come up with examples to say, look, this is the one that failed, and this is why I think it failed, and so on. And I think this tells us about Travis' approach to research. He's interested in trying to find out why something works and why something doesn't work, and keep trying to improve his methods to get to make something that is better than before, rather than just happy with the improvement that he gets, right? So thank you for the opportunity to working with you, Travis, and for the nice thesis that come up from our collaboration.
Thank you, Wei Song.
Do I get to ask question too, Jeremy? All right. So I know about all the work that Travis has done. So maybe I'll ask a question more on the perspective of potential applications. So in our university, the management is trying to encourage us to break down our videos into smaller chunks, right? Let's say 20 minute chunks that summarizes what we teach, maybe in a half an hour or 1 hour lecture. So of course we can do the editing, but the question that pops into my head is that, can Travis help me? So for the type of work that you do you think it can help us to do video summarization, right? So besides segmentation, are you able to help to summarize what are the key points and nicely splice all the video segments together into something that is naturally smooth video?
So I do think that we can summarize. I mean, my work can help you summarize, but I guess now when we talk about summarization, the state of the art would be using LLM, right? But now, since you said that you wanted to make it smooth, then you will have to do editing at some point. I guess we have to match things. I do think that our first segmentation can give you a baseline of, okay, this is the first topic, this is the second topic, the third topic. And I would like to see also as well like a way to make it smooth, like you have an intro and an end for each section, right? Because right now, if you just cut it, sometimes there's not really an introduction or conclusion. So I guess we could, how to say that? There would be multiple ways to do it, right? I'm not sure. I mean, I'm sure there might be a tool at some point, or what do we? I mean, sorry, it's a really complicated question, I guess, because you need editing, you need to pick up the segments, and sometimes. So right now, I assume that usually chapters are linear, right? Like topics are linear. Like when you switch to another topic, it's a new topic. But sometimes you can go back to another topic or explain it more. So of course, the current segmentation model couldn't really do that, right? It would just cut first topic to the second topic, third topic. But then I think we could think about ways about mixing topics that are really similar. By either doing the same thing, like by running again a term, how to say that, clustering again, but without necessarily the temporal proximity. But also, I guess it's that we can also provide a way or advice to It's quite hard, sorry. I'm just thinking about all the possibilities, actually. Another thing I could think of is that we can provide an interface for people to record themselves and tell them, okay, you need to stop, you need to conclude and then go to next topic. And then we can do it like iteratively, right? So maybe first you record your whole presentation and then we tell you, okay, here's how we cut it. And then maybe provide an easy way to say, okay, at this point, maybe you can just record a conclusion to this topic.
Right.
There's a lot of actually ideas, so that's why I was a bit confused. There's so many things we can do with that. Yeah.
Okay, nice ideas. Yes, thank you.
So I sent you to
Can you hear me? Yeah. Okay, so thank you, Fabrice. I don't have any questions. I will just add on what Geraldine and Moissan said about the pleasure to have you with the team. So maybe to give a little bit more context. So Travis has done a PhD between Singapore and France. He has actually spent quite a lot of time in Singapore. That's the first difficult context. The second difficult context is due to the fact that Vincent, so the original supervisor here in France, had to leave during the PhD. So that's where I came in. So Travis had to experience a change in supervisors. And the last part of context, which is really the most important one, is the fact that he was in the technical work, as has been said before, that it was always changing. So have maybe a story about that. So one of the slides that Travis showed during the presentations is the one where he tries to extract the structure of the slide. So like Markdown, for example. So he has spent quite a lot of time working on that until ChatGPT 4 went out. And so Zero Shot was working better than anything that Travis had done during the past maybe 4 months. Which, I mean, as you know, for a PhD student can be quite depressing. The nice thing with Travis is that the depression only lasted a few minutes, and then he went back on the saddle, and actually we changed a little bit the ideas that he worked on. That's where he worked on object detection and finally was able to make a nice publication. So I think it represents well what Travis is when you work with him. He's always positive, always full of energy, always smiling. It's really a pleasure to work with Travis. I think everybody in the team can say the same. And in a more general way, I can also say that from the beginning of your PhD till the end, I mean, the evolution is quite impressive as well, because you went from a lot of necessary advice to now you just come to me and you say, okay, I have seen this paper, I have implemented it, now it works. It works not so well, but I have made an improvement, and so we have pretty much nothing to do, which is nice. So all these ideas that Travis has presented about segmenting the blackboard and having this new event of erasing, he had just done that after writing the manuscript and before the defense in a few days, I guess. So really, I mean, it's nice to see that you've grown up as a researcher and you're ready for the real life. Give the floor back to you, Joanne.
Yeah, thank you. I think Vincent is going to conclude the round of questions and, and remarks.
Hello, can you hear me well?
Yes.
Yes, okay. So thank you, Geraldine. Thank you, President. I'll be very brief because I've been away from Toulouse for over 2 years now, so I have very little to say. I would like to thank my external colleagues for their examination work. Thank you, Laurent. Thank you, Munim. And thank you, Muriel. I think that everybody understood that, but I would like to clearly underline that this thesis was totally supervised by Axel Carlier in Toulouse and with Seng from Singapore. That is why I leave it to them to comment on the quality of the interactions with Travis. And I would simply like to thank my colleagues at Reva and HiPal for the actual supervision. Finally, I would like to congratulate Travis on this solid piece of scientific work. It was a nice presentation and a nice discussion today. And of course, I wish you all the best in your career. So it could be summarized as maybe be more than an engineer, remains a doctor, but maybe I should say remains a researcher before the today conclusion. So thank you, Travis.
Thanks a lot. I think we'll try to, we have to deliberate and we'll try to be brief, but because the people are online here, it's maybe easier if we ask the people around. I should ask first if there is someone that is a doctor and wants to ask a question. Okay. And if not, we'll ask the people in the room to leave us so we can just quickly deliberate and then we'll catch with you. Okay, so after this long session where we talked a lot, you'll have to talk also. So I'm going to talk first, and you'll have to give this oath at the end. You really deserve your PhD. So Travis, you addressed in your PhD very timely topics on multimodal analysis of pedagogical videos. You defended your solid scientific research work with a very well illustrated and structured presentation. As in the manuscript, you have situated your very interesting and very instructive work and highlight your main contribution with respect to the state of the art. Your research skills have led to you to work with a very methodic research approach, and the jury also highlighted that on top of this research, you have produced outstanding developments of tools for the scientific community, tools that are not only prototypes but also in a very advanced development stage, and that are also very user-friendly. You have answered with clarity and with honesty the numerous questions of the jury that have been deriving a wide spectrum of topics. You demonstrated your deep understanding of the topic in this research context. Your work opens the door to new publications on top of the one you already have, but also for the scientific community, and the tools you developed also opens the door to new contributions for you or for the community. So thank you for that. And before you clap, you need to read the oath.
In the presence of my peers, with the completion of my doctorate in computer science, in my quest for knowledge, I have carried out demanding research, demonstrated intellectual rigor, ethical reflection, and respect for the principles of research integrity. As I pursue my professional career, whatever my chosen field, I pledge, to the greatest of my ability, to continue to maintain integrity in my relationship to knowledge, in my methods, and in my results.
So the jury unanimously wants to give you the grade of Doctor of University of Toulouse. Congratulations. Again?
Thank you. I would like to address my thanks to everyone. So I want to start by the member of the jury. So thank you, Geraldine, to be the president of the jury. I ask you because I mean we know each other, and it was always been a pleasure to help you also. So and yeah, that's what else to say. And then I would like to thank the reviewers. I want to thank Moni and Laurent to have given me such constructive feedback on my manuscript, and to have accepted to be a part of my jury. Thank you very much. And then I would like to thank you, Miriam, to have been my examiner, and also you provided excellent questions, and I really thank you for that. And now I want to also thank my supervisors, right? So starting by Vincent. Thank you, Vincent, for everything. Yeah, sorry. And thank you for actually believing me for doing the PhD. Right? So I would like to thank you for that. I would like to thank Axel. You see, I mean, we know each other a lot. I mean, we always see each other. So thank you. It was also a pleasure to work with you. for your warm welcome in Singapore. I really feel appreciated there. And your words helped me a lot. Even though, I only stayed like for 6 months, and you have been a great help. So thank you. And also thank you for all the meetings that we had. Not in the same time zone, I know it was difficult. Thank you. And now I would like to thank all my colleagues in the team. So it was always a pleasure to go at the lab because there was always a lot of people, and now there's even more people, and it's very fun to be with you guys every day. And I would like also to thank all my friends. So some that came from far, some that came just there, just from here. Your great support, even though you don't really understand what I'm doing sometimes. So thank you a lot. And I would like to thank especially the trio, I want to say, which is Marie and Remy. Like Remy wasn't able to be there, but him and Marie was a great help and great support for my PhD. And now I want to thank my family, so my parents there, and my brother. And thank you for giving me, and also you pushed me to do a PhD, so. Thank you very much, because I really like it. I really enjoyed my experience so far. Thank you for everything. And now I would like to thank my partner, Sherry, who arrived from very far to see my presentation. You've been a great emotional support, and you always believe in me. Thank you. So we're going to do a small party just to celebrate, we're going to celebrate. So, donc il y a un pot salle de convivialité de 27, presque dans quelques minutes. Il faudra qu'on aide peut-être à déplacer les choses. Donc voilà, vous êtes tous invités bien sûr. Et à quelle heure? Je pense que là je pense qu'on va y aller.